Hi, this is question number 18 of set D of the IIT JEE 2017 main paper, and the question reads, this point P having coordinates root 2, root 3 lies on the hyperbola, and we have a focus of the hyperbola as 2, 0 and the other focus as minus 2, 0. So the foci are plus or minus 2, 0, and we have to find tangent at this point P to the hyperbola, which passes through which of these 4 points. So we've been given that this point P lies on the hyperbola. We have also been given the foci of the hyperbola, and we have to find which of these 4 points lies on the tangent to the hyperbola at this point P. Well, the first thing you note is equation of hyperbola is, because the foci are at plus or minus 2, 0, this is the standard hyperbola with the equation x square minus upon a square minus y square upon b square is equal to 1. So we're talking of this standard hyperbola centered at the origin, because the foci are plus or minus 2, 0. Well, we know that for such a parabola, the foci are at plus or minus AE, 0, where E is the eccentricity, and A and B are the parameters, as we know, the semi-major and semi-minor axis. And so AE with the plus or minus sign is equated to plus or minus of 2. So equating these two, the first coordinates of these two results, we can say that AE is therefore equal to 2. So we obtained the value of A into E as equal to 2. Now note that if you square this, we will obtain A square into E square is equal to 4. So we are squaring both sides, so we get this result. Well, the next thing you note is the relation between AB and the eccentricity E. Well, for a hyperbola, the relation is somewhat like this, that P square is equal to A square into E square minus 1. So when you're talking of such a standard hyperbola, the equation for the hyperbola that involves B square, A square and its eccentricity are as shown. Well, in this equation, you can further write this as, this will imply that B square is equal to A square into E square minus A square. So I've just split this right hand side, and now A square into E square is equal to 4. So I can now write B square is equal to 4 minus A square. From this we obtain the result that A square plus B square is equal to 4. So this is the first result that we've obtained, and we will now proceed to see what else is required. Well, note that because this is a tangent that we are talking of, we know that equation of tangent, so I'll write the result here. Equation of tangent to hyperbola of the form x square by a square minus y square by b square equals 1 is given by, so we'll write the general equation of tangent to this hyperbola at a given point x dash comma y dash is x into x dash upon a square minus y into y dash upon b square is equal to 1. So this is the equation of tangent. So I'll write here tangent to the hyperbola at point x dash comma y dash. So this is the equation of the tangent. So we will box this. Note that now, because this tangent, or rather this tangent passes through P root 2 comma root 3, we will now substitute x dash is equal to root 2 and y dash is equal to root 3 in this equation, and so we will get a result for a square, b square and for x and y. So now we will imply that, let me make some space for my solution. Now note that because this is the case, if I put x is equal to x dash, we know that x dash equals root 2 and y dash equals root 3. So this point root 2 comma root 3 lies on this tangent, because this tangent itself passes through that point, or rather this is a tangent at that point itself on the hyperbola, and so we can write this implies that putting x is equal to, or rather putting x dash is equal to root 2 and y dash is equal to root 3, from this given equation we will now get x into root 2 upon a square minus y into root 3 upon b square is equal to 1. So this is an important equation of the tangent that we've obtained. So we will write this as tangent equation for this given hyperbola. Well, now note that we will double box this result, because this is very important for a later analysis. So we have obtained x square, or rather x into root 2 upon a square minus y into root 3 upon b square is equal to 1. And this is the equation of the tangent. But now we have to check which of these 4 points satisfy this equation, that is, which of these 4 points lie on this tangent. So we've now identified this first equation, that a square plus b square is equal to 4, and we will call it equation 1. Now we will turn our attention to this condition that is given. Note that because P lies on the hyperbola, these two coordinates, or these coordinates of point P will satisfy this equation of the hyperbola. So if we substitute x is equal to root 2 and y is equal to root 3 in this equation, then what do we get? Well, putting x is root 2 and y is root 3 in this equation gives us 2 upon a square minus 3 upon b square is equal to 1. So this is yet another equation that we obtained. So we'll box this one as well. Well, note that this was our equation 1 and this becomes our equation 2. So we'll regard this as our equation 2. So now this becomes our equation 1 and this is equation 2. And now when you solve these simultaneously, let us see how we can solve these two equations simultaneously. Well, note that because we can substitute b square is equal to 4 minus a square, we will now write this implies 2 upon a square minus 3 upon b square. Now b square can be written as 4 minus a square. So I'm writing b square as 4 minus a square here and equating this to 1. Well, if you solve this further, you will equalize the denominators and so you will get 8 minus 2a square minus 3a square will be now equal to this term taken on the right hand side. And so if you simplify this, you will get is equal to 4a square minus a to the power 4. So I've taken this denominator here. Next, from this equation, we obtain a quadratic in a square, which can be easily solved. Now, when you rearrange this equation, you will get a to the power 4 on the left hand side, plus you will then get a sum of all these terms, which should be minus of 9a square, and then you get a plus 8 on the left hand side, and then all the variables taken on the left hand side leaves you with a 0 on the right hand side. Well, now this is a quadratic in a square, which can easily be solved. And if you find the roots of this equation, you will get a square minus 8 and a square minus 1 is equal to 0. So the product of these terms is equal to 0. So now if here you consider a square is equal to 8, so I'm considering a square is equal to 8 first. If a square is equal to 8, then this will imply that a square into e square, which is equal to 4, will now give us the result that 8 into e square is equal to 4, which will give us the result e square is equal to half. But we know that for a hyperbola, the eccentricity square can never be less than unity. The square of eccentricity is always greater than unity. And so, a square cannot be equal to 8. And so, we discard this solution that e square cannot be less than 1. And so, we discard this solution and therefore conclude that therefore, a square is equal to 1. So, we've obtained the value of a square from this. Well, now because a square is equal to 1, we know the value of b square will be 3. And so, we can now write therefore, b square is equal to 3 because a square plus b square equals 4. So if a square is 1, b square is 3. So this is another result that we obtained. Now the rest is pretty easy. We just have to simplify or rather substitute a square and b square in our equation of tangent. And so we get the equation of tangent as x root 2 upon a square, which is 1, minus y root 3 upon b square, which is 3. So we get y root 3 upon 3 and this will be equated to 1. So the final equation that we have obtained is x root 2 plus or rather x root 2 minus y root 3 upon 3 is equal to 1 is the equation of tangent. So we write tangent equation. This is the tangent to the given hyperbola. Note that out of these four alternatives, when you try the first alternative, it does not give us the right hand side equal to 1 and so we discard this. Continuing serially, if you try the second equation, you will note that if these coordinates are put for x and y, these coordinates do satisfy this equation and so we regard this as the answer to our question. And so we finally report that the answer here is 2. Answer is this option number 2 of set D, where we can now write 2 root 2 comma 3 root 3 lies on the tangent to this hyperbola. And so the final answer is 2 root 2 comma 3 root 3 is the coordinate of the point that lies on the tangent at P to this hyperbola. So the correct option to this question is option number B. Well, because there are only one option right amongst these four, there's no need to check the further ones, and so we've directly concluded that this is the right answer to this question.